Hey, welcome back to Mr. Rockenstein and Mr. Moore's Flipped Classrooms. Today we're working with fractions again, and we are working on improper fractions and mixed numbers. Two goals today. First goal, you will be able to represent a fraction that is more than one whole using an improper fraction. And two, you will be able to represent a fraction that is more than one whole using a mixed number. So these are really our two key terms today, improper fraction and mixed number. So let's get to talking about those. Um, Here's a question that we need to answer today. What do we do if we need a fraction that is greater than one whole? Now you may be sitting there saying, Mr. Rockenstein, you just got done telling us that fractions are all about things that are smaller than one whole. And that's true. That's why we have fractions, but sometimes we need those smaller pieces, but with them we're going to make something that is more than one whole. Let me give you an example. Imagine that you were at an after-school class and it was snack time. The snack is apples, but there aren't enough apples for everyone to have a whole apple. Instead, each person gets one half of an apple. You are sitting at a table with two friends, and the teacher asks you to get enough halves for your table. How many halves do you get? So let's think about this situation. We can draw a picture here. You're sitting at the table, and there's you, and you got a friend here, and you got another friend here. So there's three of you, and you need to get apples for all of them, by the way. This is you. That's you. So how many halves do you need? Well, there's one of you, and then there's your two friends. So you need one half, two halves, three halves. So each of these is a half of an apple. It's not a whole apple. So you would call this, as a fraction, you would call this 3 halves. Now, another way to think about it is if you took one whole apple and then a half of an apple, that would also work, right? Because we could take this and cut it into halves, cut it in half, and you could have this would be one half, and this would be one half, and this would be one half. But if we leave it as a whole apple, we've got one whole apple, and right here we've got one half apple. Same amount of apple. These two are equal. Just two different ways of writing it. One, we write the whole. One, we're just writing the pieces. All right, so here are our two terms again. One, we've got improper fractions. And the improper fraction is that first one that I showed you. That's 3 halves. It's where we just have the pieces written down. How many pieces do we have? Now it's more than a whole because a whole would just be 2 halves. The second one is a mixed number. That's where we had the whole number 1 and then a half. It's a whole apple. It's a little big. A whole apple and then a half of an apple. Here's our one whole. Here's our half. These are all halves right here. And so we say 3 halves. But remember, these two are equal. 1 and 1/2 is the same amount as 3 halves. They're equal to each other. It's just that when we write with a whole number, we call it a mixed number, and when we write with just these parts, or a numerator that's bigger than the denominator, we call it an improper fraction. All right, let's do some example problems here, and we can use pattern blocks to help us. something that's really important to keep in mind whenever you're doing any kind of fraction problem is what is the whole. So in our problems here, um, one hexagon is going to be the whole. So if I put out one, two hexagons, and I asked you to write what that represents, I would expect you to write 2, because this is one whole, this is one whole. You put those together, one whole and one whole is 2. All right, so let's try something else. Get rid of these. Let's put out a trapezoid. If we compare that to the whole, and this is a smaller version, but we saw the big version of the whole right here. Um, if we put out just the trapezoid, I'll get rid of this big one. A trapezoid, this trapezoid would equal 1/2, because half of a trapezoid, or half of a hexagon, is a trapezoid. And I can show you that by putting another trapezoid out here. And I'll spin it. If I put them together, I get a hexagon. So this is also 1/2. So if I have 1/2 and 1/2, I put them together and I get 2 halves, or I get just one whole. Now, what if I add another half? How could we write that? I could write that as, well, this is 1/2, this is 1/2, this is 1/2. So I could write that whole thing as 3 halves. Or I could bring these kind of together and think of that, instead of thinking of that as 1/2 and 1/2, I could think of that as one whole, and then I have one whole and 1/2, and then I would write that as 1 and 1/2. All right, now I'll add another half to the mix. Now I've got, if I want to look at it this way, I've got 1/2, 1/2, 1/2, 1/2. Put it all together, that's 4 halves. That's my improper fraction. It's also going to have a mixed number or a whole number equivalent. Let's see what it would be in this case. So I put this together. Oh, what happened there? And we'll call that one whole. And then I'll move this, and actually I'll rotate it. Whoa. There we go. And I'll put it together, and I'll call this one whole. And so instead of 4 halves, I can just write 2, because 1/2, or excuse me, one whole and one whole is 2. Okay, let's try this with a different shape. I've got my whole here, and now I'm going to bring out a rhombus. Let's see how many of these can fit into a hexagon. 2. It looks to me like there's space for one more. Yep, right there. So we know that this piece right here, if 3 of them make up the whole, then this rhombus must be 1/3. And if I bring this one down, then I've got another 1/3. And if I bring this one down, I've got another 1/3. And altogether, those would be 3/3, or one whole. Now, what if I bring out another third? So I've got all these out here. Then I've got one third, one third, one third, one third. And that would equal, all together, that would equal 4/3. That's my improper fraction. But I can also then put them back together, and I'll pause it and do that. If I put them together like this, I can call this whole shape one whole, and this is 1/3. So together, they would be 1 and 1/3. All right, the last shape I want to show you is a triangle. We've got to see how many of these triangles will fit onto our whole. Uh, well, we can fill half of our whole with 3. So I would say the whole thing would be filled with 6. So I can take one of these triangles out of here and I can call it, it's 1/6. And I can take this one down here and this one down here. And then I'm going to add another one, another one, and another one, and another one. And I want you to pause the video and I want you to tell me what this would be as an improper fraction and as a mixed number. I have all of these triangles. So one way to look at it is that each one of these is a sixth, now that you've had a chance to do it. Oop, sixth, 1/6, 1/6, 1/6. And I count 1, 2, 3, 4, 5, 6, 7. So altogether they would be 7/6. Now what's the mixed number where we have a whole number? Well, how many of them make a whole? I'm not going to make the whole, but how many of them make a whole? 6 of them make a whole. So I'm going to put down 1 because I've got 6 of them. 1, 2, 3, 4, 5, 6. That's a whole. And then I've got 1/6 left over. So I'm going to put that over here. So 7/6 is equal to 1 and 1/6. Now, here are a couple of problems for you to try on your own. So you can pause the video here, try them out. I want to know what this would be as an improper fraction and a mixed number. And then I want to know what this would be as an improper fraction and a mixed number. So pause the video and try it out. Okay, so a quick explanation. We know that triangles are sixths, and we know that they're sixths because our whole is still this hexagon. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 sixths, because each one is a sixth, and there's 9 of them. Now I know that 6 of these will make a whole, so I'm going to cross out 6. 1, 2, 3, 4, 5, 6. That's one whole, so I'm going to go over here. Can I make another whole? No, because I've only got 3 left. So that's going to be 3/6. So 9/6 is the same as 1 3/6. Over here, I've got a little problem because I've got a half, I've got a third, and I've got 2/6. So the key to doing this problem is to change my third and my half. I'm going to try to change them into sixths. So here I can just draw a line across, and now I've got a sixth and a sixth because those are both triangles now. And in a third, or excuse me, in a half, I draw lines like this, and now I have a sixth, and a sixth. So I have 1, 2, 3, 4, 5, 6, 7 sixths. 7/6. Do I have any holes? Well, yeah, 6/6 would be a hole. So there's 1, 2, 3, 4, 5, 6. That's a hole. I got 1/6 left over, so 1 and 1/6. So 7/6 and 1 and 1/6 are the same. So now you know how to find improper fractions and mixed numbers. We'll do some practice in class. Remember to watch any parts that you didn't understand over again and pause and definitely figure out those problems. See ya.